Dear students, I am Dr. Tamrakar from Bharati College of Engineering and Technology. I am teaching fluid machinery in B 5th semester. Next question is, an inward flow reaction turbine has an exit diameter of 1 meter and its breadth at inlet is 250 mm. If the velocity of flow at inlet is 2 meter per second, find the mass of water passing through the turbine per second. Assume 10% of the area of flow is blocked by blade thickness. If the speed of the runner is 210 rpm and guide bed angle makes angle of 10 degree to the wheel tangent, draw the inlet velocity triangle and find first the runner vane angle at inlet, second velocity of whirl at inlet, third the absolute velocity of water leaving the guide vane, and fourth the relative velocity of water entering the runner blade. So here the data given are the external exit or external diameter d1 equal to 1 meter, width at inlet d1 equal to 250 mm, equal to 0.25 meter. Velocity of flow at inlet Vf1 is 2 meter per second. Area blocked by vane is 10%. Speed 210 rpm. Guide bed angle is given 10 degree. Tangential velocity of wheel at inlet u1 equal to pi d1 and by 60, putting the values here, pi 1 into 210 by 60. This value of u1 comes 10.99 meter per second, 10.99 meter per second. Area blocked by vane thickness is 10%, so this area blocked by vane percent 10% is 10% of pi d1 b1. This is the area blocked, that is equal to 0.1 pi d1 v1. Actual area through which the flow takes place, so the actual area through which flow takes place that is area equal to pi d1 v1 minus 0.1 pi d1 V1 equal to 0.95 V1. That is putting the values here 0.95 into T1 is 1 and V1 is 0.25. So this area comes 0.7068 meter square. So mass of water passing per second we have to calculate, and the Venn diagram of this turbine inlet triangle. This is the inlet triangle. This is angle alpha. This is V1, angle theta, VF1, VR1, U1, VW1. This is the inlet triangle. Now we have to calculate the mass of water passing per second. So mass of water passing per second, water passing per second is rho A VF1, putting the values here. Rho is 1000 for water. Area we have calculated, that is 0.9%, 7068 into VF1 is given 2. So this mass comes 1413.6 kg. Now we have to calculate runner vane angle at inlet. Runner vane angle at inlet. This is angle theta. From inlet to exit angle, tan alpha equal to VF1 by VW1. This is tan alpha. VF1 by VW1 is tan alpha. That is equal to 2 by VW1. So VW1 equal to 2 by 10. So this comes 11.34 meter per second, and tan theta here, tan theta equal to VF1 by VW1 minus U1. This is the VW1 minus U1 equal to VF1 by VW1 minus U1. So this is 2 by 11.34 minus 10.99 equal to 5.714. So this angle theta is equal to 80.07 degree or 80 degree and 4.2 minutes. This is the value of angle theta comes. Next, second is the velocity of speed at inlet. Velocity of speed at inlet U1 we have calculated is 10.99 meters per second. We have calculated earlier. Then next is the absolute velocity. The absolute velocity of water leaving the guide. Water leaving the guide when V1 from inlet triangle here sin alpha equal to VF1 by sin alpha equal to VF1 by V1. So this is sin 10 and VF1 is 2 by V1. So the value of V1 comes 11.517 meter per second. Now next we have to calculate the relative velocity of water entering the runner plate. Fourth, the relative velocity of water entering the runner blade. Water entering the runner blade VR1. Here sin theta equal to VF1 by VR1. That is sin 80.07 equal to 2 by VR1. So VR1 equal to 2.03 meters per second. So you have to solve some more numericals on the topic that will be helpful for you, and it will be helpful to take the questions from the university paper from the site of CS video. These two questions was important, and this one has been asked in examination in year 2008. We will continue next problem. Next, we will take next question. The external and internal diameter of an inward flow reaction turbine are 1.2 meter and 0.6 meter respectively. The head on the turbine is 22 meter and velocity of flow through the runner is constant and equal to 2.5 meter per second. The guide blade angle is given as 10 degree and the runner vanes are radial at inlet. If the discharge at outlet is radial, determine first the speed of the turbine, second the vane angle at outlet of the runner, and third hydraulic efficiency. Here the data given are external diameter B1 is equal to 1.2 meter, internal diameter D2 is given as 0.6 meter, head is given 22 meter, velocity of flow Vf1 equal to Vf2 equal to 2.5 meter per second. Guide bed angle alpha is given 10 degree. Runner vane radial at inlet means theta equal to 90 degree. So VW1 equal to U1 VR1 equal to Vf1 equal to 2.5 meter per second. This charge is radial, so VW2 equal to 0, V2 equal to Vf2 equal to 2.5 meter per second. From inlet velocity triangle, you have to draw the velocity triangles here, inlet and outlet velocity triangle, both are radial. From this inlet velocity triangle, tan alpha equal to Vf1 by U1. Putting the values here, tan equal to 1.5 by U1. So the value of U1 comes 14.178 meter per second, and VW1, as we know, VW1 equal to U1 equal to same 14.178. Now we have to calculate the speed of turbine. Speed of turbine, and as we know, U1 equal to pi D1 n by 60. So here this is 14.178 equal to pi into value of D1 is given 1.2 and by 60. So here the value of n comes to 25.65 RPM. This is the value of n. Second, we have to calculate the vane angle at outlet of runner. Vane angle at outlet of runner. That is angle phi. Angle phi. So U2 equal to pi D2n by 60. Putting the values here, pi into D2 is 0.6 and we have calculated just 225.65 by 60. So this value of U2 is 7.09 meter per second. From outlet velocity angle tan phi, here tan phi equal to VF2 by U2, VF2 by U2, putting the values here. VF2 is 2.5 and U2 we have calculated 7.09. So this angle phi comes 19.42 degree or 90 degree 25.2 minutes. Next we have to calculate the hydraulic efficiency. The hydraulic equal to VW1 U1 by GH, putting the values here 14.178 into 14.178. Both VW1 U1 are same. This is 9.81 and H is 22 meters. So this eta hydraulic comes 0.9314, that is 93.14% is the hydraulic efficiency of this turbine. So you have to solve more and more questions